All right, so this is number 32. So in 32, you're given the function f of x, which is this quadratic function here, and is represented as negative 3x squared plus 4x minus 1. And you want to find f of negative x. So let me go ahead and just rewrite this real quick. So f of x is negative 3x squared plus 4x minus 1. And remember what f of negative x means. So to find f of negative x, I go to my function f, which is here, and wherever I see that variable x, I'm going to circle it. Wherever I see that variable x, I'm going to substitute negative x. That's what that means. So when I come here, I'm going to say f of negative x will be negative 3 times negative x squared, because that's what that said to do. In place of x, I substitute negative x, plus 4 times negative x minus 1. All right, now remember, you got to do the order of operations first. So you got to square before you multiply. You got to do exponents before you multiply. Remember, negative x squared means negative x times itself, doesn't it? Well, negative x times negative x is a positive x squared. So negative x squared is a positive x squared. So that's what this becomes. So this becomes negative 3 times x squared. 4 times negative x is a negative 4x and then minus 1. And then you look at this and you ask yourself, can I simplify this further? Can I combine like terms? And the answer is no. So there's your answer. So what you found is this. You found f of negative x is going to equal, and in the blank you would put negative 3x squared minus 4x, minus 1. Okay? All right, letter B. Now you want to find f of x minus 1. So remember, let's go back to our function f. And our function f was negative 3x squared. Lord. All right, let's do this again. Negative 3x squared plus 4x minus 1. So again, just like we did before, I'm going to circle the variable x. And so wherever I see the variable x, I'm going to substitute x minus 1 this time. Okay? And so then I'm going to get negative 3 times x minus 1 squared plus 4, and in place of x, I substitute x minus 1, and then minus 1. So this is this, okay? All right, so wherever I saw the variable x, I substituted x minus 1. You can see I'm doing that. X minus 1, x minus 1, okay? All right, now I've got to simplify this, so I've got to multiply all this out. So I've got to think about, remember, just like we did here, I had to square first before I multiplied, right? So I got to square first before I multiply. So let's think about what x minus 1 squared is. So x minus 1 squared means x minus 1 times itself. So I also know how to multiply two binomials. I'm going to go ahead and use the FOIL method. So when I do that, I get x times x is x squared. The outer is a negative x, and the inner is also a negative x. So remember, whenever you square a binomial, the outer and the inner are the same. You're going to have two identical terms here. A negative 1 times a negative 1 is a positive 1. And now combining those two identical terms, I get x squared, a negative x, and a negative x is a negative 2x plus 1. So x minus 1 squared is this trinomial right here. So that's what this becomes. So this becomes negative 3 times x squared minus 2x plus 1. Okay? Now over here, I'm going to go ahead and distribute, because I can distribute here because x minus 1 is being raised to the first. So I get 4x minus 4 and then minus 1. Now I can distribute this because x squared minus 2x plus 1 is being raised to the first. So I can use the distributive property. And so negative 3 times x squared is a negative 3x squared. A negative 3 times a negative 2x is a positive 6x. A negative 3 times 1 is a negative 3. And I'm going to go ahead and rewrite all this over just like this. And now I need to ask myself, can I simplify this expression any further? And the answer is yes, because these terms here are like terms. These terms here, those three here, are like terms. So putting this in descending order, I get negative 3x squared. 6x and a positive 4x is 10x. Positive 10x. A negative 3 and a negative 4 is a negative 7. A negative 7 and a negative 1 is a negative 8. And so there's your answer. So you would say f of x minus 1 is equal to, that should be a negative right here, negative 3x squared plus 10x minus 8. Okay, so that's the answer there. All right, let's look at the next one. Okay, so in 33, you had this kind of problem. So you were given a function g that is a relation in which you have a finite set of ordered pairs. So I have one, two, three, four, five. Five sets of ordered pairs, and it is a function because you have function notation. You could even look at this and notice that for each of those x values, there was only one y value. Okay, so that's a function. What I want you to do though is I want you to determine these expressions here. So I want you to tell me what would be g of 2 plus g of negative 8. Well, it's not that difficult. That's a fairly simple problem. It is very simple. You got to just remember what g of 2 means. G of 2 means what is the y value when x is 2? Well, when x is 2, you look over here and see where x is 2. Well, x is 2 right here in it. There's where x is 2. So if this says x is 2, then that means my y value is what? Negative 8. So g of 2 is a negative 8. I do the same thing here. Plus, plus. Then, remember, if we cover this part up, g of negative 8 means what is the y value when x is negative 8. So I'll go up here and I'll find where x is negative 8. Well, x is negative 8 right here in it. So there's my x. So that means my y value is 6. So that's 6 here. And then you add them up. Negative 8 plus 6 is a negative 2. There's your answer. So in the blank, you would say g of 2 plus g of negative 8 equals blank. You would put negative 2 in that blank. All right, very simple, not that difficult. Over here, it's very similar to this, except right here, I'm going to cover this part up here. This, you got to recognize that 3g of negative 2 really means this, 3 times g of negative 2. All right, and whatever that is, you're going to be subtracting from g of 4. All right, so the way I would do this is I would find g of 4 first. So let's find g of 4. So remember what g of 4 means. G of 4 means what is the y value when x is 4. So I'll go up here and I'll find where x is 4. Well, x is 4 here, right? So when x is 4, what is my y value? My y value is negative 1. So this is negative 1. Minus 3 times, see how I'm doing this? Minus 3 times, and then I find g of negative 2. So g of negative 2, if I cover all this up right here, g of negative 2 means what is the y value when x is negative 2. So I go up here and I find where x is negative 2. Well, x is negative 2 right here. That means my y value is 7. So this is 7. So I have negative 1 minus 3 times 7. And I know that 3 times 7 is 21 in it. So this is minus 1 minus 21. And I know that a negative 1 and a negative 21 is a negative 22. And so there's your answer, negative 22. So g of 4 minus 3 times g of negative 2 will equal blank. And in that blank, you put negative 22. All right, so that was number 33. It's not a difficult problem. It's very, very simple to deal with. All right, now finally, this is number 34. All right, so here's 34. So 34 says, given the graph of this function right here, function f. So you're given this graph, you want to find this information. So first of all, you want to find the domain. Now remember, when finding the domain, you're going along the x-axis like this. That's how you're doing this. I want you to notice, though, there are no arrows on the ends. You have a closed circle and a closed circle. So since there are no arrows on those ends, you're not going to use infinity or negative infinity at all. So when you think about domain, you're going along the x-axis. So when I go along the x-axis, this is where my graph starts. So notice it starts at negative 6, doesn't it? So I'm going from negative 6 all the way, so every real number along the way is going to be on this graph for x. So notice that when I go along the x-axis, all these x values here will be a point on that graph. So I'm going from negative 6 all the way to, and then it stops at x equal 5. Okay, notice the closed circle. All right, so I'm going from negative 6 to 5, and so the domain, you're going to say negative 6 with a bracket, because the closed circle. Those are both closed circles. Negative 6 comma 5 bracket. So that's your domain. The range, you got to look at this in terms of the y-axis. Remember, when thinking about the domain and range, those are intervals, and you always write an interval from smallest to largest. So that's why you see negative 6 first and then 5 second. So when doing range, you go from bottom up along the y-axis. So notice again, no arrows, right? So you're not going to be dealing with infinity, negative infinity. But as I go along the y-axis, I touch the graph at this point here, right? And so you got to ask yourself, well, what is that y value? Well, that y value is a negative 5 in it. So I'm going from negative 5 all the way, and then you keep on going until you reach the highest point. Since there's no arrow, then my highest point has to be here. Okay, that's my highest point. So my range is going to be from negative 5 all the way to a positive 5. That's your range. From a negative 5 all the way to a positive 5. All right. And again, brackets, because there are no open circles at all. These are all these are closed points. These are points in the graph. None of them are open circles. So you're going to say bracket negative 5 comma 5 bracket. All right. Then you want to find f of 4 from the graph. So remember what f of 4 means, just like we talked about what it meant here. So f of 4 means what is the y value when x is 4. So I go to my graph and I look at where x is 4. X is 4 here. So I look at the point that's associated with it. So that point associated with it is right here. So that means that if I were to put the coordinates when x is 4, my y value is 3. And so now I have enough information to answer this question. My y value when x is 4, my y value is 3. So 3 goes in the blank. All right, the next one, I want to find f of negative 5 plus f of negative 6. So again, f of negative 5 means what's the y value when x is negative 5? Well, when x is negative 5, there's where x is negative 5, I locate the point that's associated with it, and that's this, right here. It helps to indicate the coordinates. So the coordinates of this point is negative 5 in it. So when x is negative 5, my y value is negative 5. So I'm going to put negative 5 here. Okay, plus, and then I find f of negative 6. Well, f of negative 6 means what is the y value when x is negative 6? Well, here's where x is negative 6, right here. The point associated with it is this point here. If I label that point is negative 6 comma negative 2. So that means that when x is negative 6, my y value is negative 2. So f of negative 6, what's the y value when x is negative 6? It is negative 2. So put negative 2 here. So now negative 5 plus negative 2 is a negative 7, and that goes in the blank. And that's how you do this. All right. So that was numbers so we just did numbers 32, 33, and 34. All right, so that set is kind of easy. It's not a difficult process, fairly easy to deal with. And when we did number 32, just be careful of your operations. You got to do exponents before you multiply. Same thing here, exponents before you multiply. You did have to go on the side, though, and figure out what x minus 1 squared. Now remember, when you square a binomial, you're always going to end up with a trinomial. So keep that in mind. All right, so that is it. So that is the key to those three problems.